So speaking of footprint, what's your take on the Chinese spy balloon? Because it seems like, as far as taking pictures, I mean, that could be done with a satellite and probably is done all the time. Um, Even at 60,000 feet, it can get, I think it can get, which correct me if I'm wrong, it can get some more signals, but still I think a lot of the signals would probably be out of range. And even if it could, wouldn't those signals be encrypted? And they could also still jam the satellite, or sorry, jam the balloon?
So, a couple things here, and I'm mostly going to be answering this question from my amateur radio perspective than my Navy perspective. So, got my little Baofeng right here, also made in China, coincidentally enough. But at 60,000 feet, you're looking at 12 miles versus satellites are operating up at 300 all the way up to 22,000 miles away from the Earth.
Is 300, is that the low orbit?
That's the low. And those ones are going around the Earth every 90 minutes. So usually those ones are used to transmit information down. Sometimes you'll have those used for imagery. You can get better resolution being so close, but they are going by. And the other thing about a satellite is, there's this big potential picture that it can see, but as the satellite is going by, you're essentially looking through a soda straw. And so the satellite is coming through, it needs to look at something, and then it's out of focus and it's on to the next thing. So you're getting a tiny soda straw look at the Earth. So if there were cameras on something 12 miles above, you can get much higher quality pictures than if you're 300 to thousands of miles up in the sky. I don't know necessarily if they had anything like that on there, but it's possible. Next thing, as far as what signals are you going to be able to detect, there's a huge difference there. So HF and VHF signals get attenuated by the ionosphere. So they get refracted, which causes them to shift in the direction that they're going. And what this means is you can use that to essentially bounce signals off of the ionosphere. This is why AM radio stations travel much further at nighttime, because they're bouncing off of the ionosphere coming back down to Earth. So a lot of those get garbled when they're passing through the ionosphere, and it's very difficult for the satellites to see those types of signals. All of the signals that your dish TV is sending down to Earth, those VSAT satellite dishes that we talked about earlier, those are UHF and above. So they're higher frequency than the high frequency, very high frequency. So higher up in the frequency spectrum, and they can penetrate straight through the ionosphere. But that also means that they are very focused signals. They travel essentially line of sight, whereas the high frequency, which is lower than the ultra high frequency, it's difficult because all of these have the word high in them. It can be quite confusing. The high frequency, medium frequency signals, they will spread out as they get transmitted. So they aren't as point to point. It's not necessarily broadcast because you can still have antennas that will point them in a direction, but it's not going to be as narrow of a direction. Sometimes, yes, it is broadcast, like radio stations. They operate in the lower high frequency band. And then when you really get down, there's into low frequency, very low frequency. Those also require much larger antennas because the wavelength is much longer. So in order to create that signal, you need enormous antennas. And these things go for sometimes can even circle the entire Earth, because they will develop what's called a ground wave, where it will come in, And as the energy hits the ground, it will re-induce the same thing and keep going. And they will just travel along the surface of the Earth as long as there's enough power. So the other thing is the bigger your antenna, the more power that you need going through. So with this guy, right, the antenna is only this long, so we don't need too much power to induce a current through this entire thing. Now, if the antenna were, 9 feet long, we would need more power to go all the way through. You have to overcome the natural resistance of the antenna itself. And then, of course, as they get bigger, you need to use sturdier material so that they stay straight enough to still work. They don't bend, fall apart in the middle. And as they're smaller, so inside of your cell phone, they have a rake receiver antenna. So it's a couple years ago, it was 5 antennas. It might be even more now in that, but it uses these 5 antennas. They all collect the same signal from your cell phone tower and combine those together in order to provide clear data or clear conversation. But those things are wire thin. Even if they were only this long, they would snap in half. They would fall over on themselves. So since they're smaller, less resistance, takes less power to induce a current to create that signal with that smaller antenna. But anyway, Chinese spy balloon. They're sitting here 12 miles above the surface of the Earth. They are below the ionosphere, so the signals aren't getting garbled from that HF, VHF sources. So anything that they could see from there, they would be getting stuff that would be much more difficult to clearly gather from a satellite going overhead. So next part of that, would they be encrypted? Not necessarily. So there are plenty of things that are sent out unencrypted. With all of this stuff, anything I can pick up on this guy, that's all unencrypted. Includes a lot of weather forecasts that get put out. There's a lot of warnings that get put out by the FAA, for example. Bridge-to-bridge communications from ships. So here in Virginia Beach, I can hear the guys talking to each other off the coast. You don't hear much. You'll leave it sitting for hours and then only have somebody come up once so often, because those bridge-to-bridge comms are supposed to be used for official reasons only. They're not sitting on there chatting about what they had for dinner or how long they've been waiting to get into port or anything like that. It's using it to avoid collisions, using it maybe to identify a ship that may be approaching them, that sort of thing. It's all very brief. You don't hear too much on there. And then there's also the local NOAA weather broadcasts. Those will come out and can also be used to pick up radio stations. So any of those sorts of things, those are all broadcast, and it extends well beyond that. Even when we're doing military training here in the U.S., a lot of the times for those training purposes, we may not be using our encrypted versions of our radios. So a lot of things, and that doesn't even start to touch on what our state government's doing, what our private companies doing, just all sorts of other reasons that you might have unencrypted signals floating around. And finally, why wouldn't we jam the balloon? So the problem with that is it's flying over U.S. airspace. If we are going to jam the balloon, then we are also going to be jamming ourselves. And you really run a lot of risks there, because you don't know what signals in the entire HF VHF spectrum this balloon is or is not capable of seeing. And you're going to cause interference for the entire portion of the U.S. where this balloon is currently floating over. So you'd be hurting all of your own communications, all of your own signals. And when you're jamming something, so back to Top Gun, when they're going through and trying to jam the radar so that they don't get hit by any of these missiles, you are specifically jamming that radar's frequency. If you want to jam the entire spectrum, you need to put out that amount of watts across the entire thing. So the amount of power that would be required in order to do that would just be absolutely insane. It would take like 4 floating nuclear reactors to cover that entire portion of the spectrum. So several reasons there. Another thing, it is illegal. Granted, if the U.S. government did it against said balloon, then they would have the authorities to do so. But if I use this thing, and if I just hold down my microphone and blast noise out on a channel so that other people can't use that channel, the FCC is responsible for going around and finding these sources of interference, and I could be prosecuted for jamming that particular channel. So it is not something that you want to mess with. As a radio operator, I have to take an exam, get certified, and they really hit that into you. It's like, no, there's no jamming. You can't go jam your neighbor's internet just for fun. Nope, that is illegal. So a lot of people may not know that, but there's definitely some restrictions, both practical and legal, as to why we couldn't just jam or interfere with the balloon as it's going overhead.